Smile.
Test? Okay. So welcome everybody to our talk. We are going to be talking about next generation container images. My name is Eliska Slobodova. I'm the manager in the user space containerization team at Red Hat. And Tomas Tomecek is our technical lead for all things containers. So in our team, we are obviously focused on container images, on creating and containerizing new services. Recently, we have started creating also the better workflow, so automation. So during our talk, we will show you some of our experiences, some of the struggles that we've been through during creating the services and making the pipeline and the workflow more effective. So we will start with simple Docker files. We will be creating, or we will show you ways how to create more complex container images and not to get crazy. We will show you how some ways that we've developed to ease the validation, the testing of containers, and at the end we will briefly touch the automated delivery. So basically, how to bring the content to the users, to the customers. Yeah. So, like in the center of everything, there is a container image. As you know, like probably the most widespread recipe for container. I should do it. Yeah. So in the center of everything is the Docker file. That is the standard recipe, at least for now, for defining the content. So we will show you what struggles we've been through, because you know, although Dockerfile is the most spread, it's also the best source of all the problems. So be it the simple thing that it is not easily parsable, especially in more complex scenarios where the file may extend to, I don't know, a couple of dozens lines, through configuration, which also starts in the Docker file, because many people approach it via either setting environment variables, which just makes the Docker file more complicated. And in the end, when you are trying to put more and more commands in it, it might turn into something very similar to a bash script, only much worse. So the next steps that I also mentioned is the testing of container images. So we've, probably many of other people who get in touch with the technology, started with manual testing, which of course we soon realized that doesn't scale. And also during our work, we have realized that if we want to ship container images for different distributions, or want to provide the users with multiple versions of the same application, we will very early get into the state where it just doesn't scale, because it's just too many of iteration and of the same container images. So this is what we've been through, and these were the biggest problems that we encountered. And But we have decided that we don't want to continue in this and we want to make it better. And this is what Tomas will start with.
Is it working? Okay. Thank you, Eliska, for great introduction. So usually DevConf has a theme, and I kind of missed it that it doesn't have any theme this year. So, and previously it was define the future. So let's define the future right now. Oh, can I borrow the thing? Thank you. So Eliska very nicely introduced you all the issues we are struggling with past couple of months, and we were working on tools to basically either solve them or ease them, and we'll be going one by one, or we'll present you some of the solutions. So we'll start with something simpler, which is like writing Docker files efficiently. But before we do that, let's talk about best practices. So if you actually know me, every year I do talk at DevConf, and I talk about building container images. And the reason is very simple. I mean, even these days I can go to internet, see Docker files, and see all the same mistakes people do every time. And it always bothers me, so that I want to do this talk every time until either the tooling is fixed so that it doesn't, so you are not able to make the mistakes, or that everyone knows how to do it right. But don't take me wrong, I'm not saying that I'm the good one and everyone else is bad. I'm also doing these mistakes, so actually when I was writing down these slides, it was also great education for me to actually remember all the things we always forget to do. So let's go through the list. Eliska said we'll be talking about some advanced techniques today, but before even starting with advanced techniques, you need to make sure that you have the basics right. So if the basics are not right and you are trying to, for example, make your container being configurable by environment variables, or try to employ source-to-image technology, and even though your container doesn't even build, so it doesn't make sense, so please make the basics right. And what are the basics? So for example, the first thing is security. So your container images need to be secure, which means that if you are deploying somewhere and you need SSH keys in your containers and shoveling them into container image and uploading it to the internet or even to your company registry, that's not a good idea because you can get very easily compromised. And the source of the evil is actually the container image itself, because it's composed of multiple layers, and these layers are immutable. So whenever you build a container image, push it to registry, and all the layers are present in the registry, and your users start pulling the container image, they can't change the layers, which means that whatever you put in there, it will stay there forever. And the only thing like to change it is to ditch the layer and create it from scratch. So which means that if you put your passwords, I don't know, certificates inside a container image, it will stay there forever. And there will be someone wise which will be able to extract them and use them and compromise your infrastructure. So please, there are much better tools to have secrets in your containerized infrastructure, such as you can do it via environment variables, you can mount the files inside the containers, or you can use some external service which will hold these secrets and then can just inject them into the containerized service. As I said, for these layers, so for example, when you build your container image locally, okay, so let's do a real example. So you are building container image for Nginx, and let's say we build it on top of Fedora base image. So we'll do dnf install Nginx, and that's our image. And if we don't clean the package or cache, it will stay there forever. And for example, when you push the image to registry, and in a week, someone will get it, pull it, and realize, okay, but I miss my favorite modules in there, so I want to install some additional Nginx modules. And then the person needs to get the newest metadata for the packager again. So then there are actually two copies, one of them which can't be used anymore because it's old, and then there's the new one. So it's really important to clean all the files during the build process which you don't need. And the other thing is that you will waste space on in your data center and also bandwidth, which means that, for example, if your image is 200 megabytes bigger than it should be, then you are wasting a ton of bandwidth, and you can actually save money by doing it right. So yeah, small images are definitely better than bigger one. If you think that putting all your favorite tools inside one container image and make it, I don't know, like 2 gigabytes big and putting it on the internet, no one will use it because it would take an hour to pull it, and like who would want to wait 1 hour? It's much better to actually split it to multiple images and like have one image and let it do thing right. As I said, few layers, that's also better because if you have too many layers, it takes longer to actually initialize your container because kernel needs to do all the layering of the layers, and then it needs to start the process, and there is much more, it takes much longer to actually initialize it. So yeah, few layers is better. The next tip is when you are working on a container image locally, it's a good practice to start with the things which don't change and put the things which change at the end, which means that you can iterate much faster and do the rebuilds much quicker. So for example, if you have some files which you are working on and you put them at the beginning and they are changing, so you will invalidate the cache every time and just waste time for DNF to install all the packages during every iteration, which will take minutes. And finally, that's actually my favorite, is that some people think that it's really great to put the container image on the internet and don't put any documentation there. So that, I mean, users need to figure out on their own then, like you need to read Dockerfiles, read all the shell scripts, figure out what environment variables you should be using, and you even have no idea what's the security of that container, like is it good, is it bad? So please, if you are starting a new GitHub repo for your favorite service and you want to containerize it, please put there as much documentation as possible. So in Project Atomic, we actually were thinking about it, and we developed a set of standard labels that we think that every container image should have. So for example, like name, on how to use it, where it comes from. So yeah, please employ these and you will make everyone's life much easier. And the other thing is that we are also working on like man pages for container images. So we again developed something, and you can use atomic command to actually display the man page of the container image in your terminal, and then you know what the container image is and how to use it. Okay, so I got too excited, sorry. Okay, so let's write the Docker files efficiently. So this was the problem we encountered like a couple months ago. So imagine this scenario. You have the container image for the Nginx on your GitHub. And then like you did a really great job, you are starting getting users, and some of your users tell you, okay, you're based on Fedora, but could you please make it based on CentOS, because we trust CentOS and we don't trust Fedora, or make it using Alpine because we like smaller images. And since you like your users, you employ these changes, and now we are maintaining 5 Docker files. And then your boss comes in and tells you, oh my God, this is great, we need to ship it to production, but it needs to be based on Red Hat Enterprise Linux. So yeah, you are now maintaining 6 Docker files images just for one service. And as the time goes on, and the service is getting releases upstream, and usually they change things, and the easiest thing for you is to just copy the Docker file for every version. So now you are maintaining the matrix of Docker files just for one service. So let me give you an example. So this is how you start. You have a simple Git repository, there is a Docker file, then there is a directory called root where you store all the files you want to put in the container image. Then you have makefile, because who would want to type docker build tag dash blah blah blah, or make the list much easier. And then you have readme, because you are a good image maintainer, so that there is the documentation. And as the times go on, people start asking, like, could you please add another flavor with Fedora or RHEL or Alpine? And as I said, you are now maintaining multiple Docker files. And as the time goes on, there are new upstream releases, and right now you are maintaining a bunch of files which have pretty much, they are all the same. They have just few lines different based on the version or the different operating system. But I mean, imagine that there is a typo in the label and you need to change 7 lines just for the sake of one typo. I mean, that's just nonsense. So like 4 months ago, we were actually working on the template repository for container images. So we would create a repository, and whenever we would start working on something new, we would just clone the repository, and we could start hacking right away. No need like to create README, create Dockerfile, blah, blah, blah. So luckily we had Slavek Kabrda on our team during that time, and this was pretty much the structure we came up with. And Slavek said, like, no way I'm doing this, like, it's impossible. Okay, just leave me be, give me 2 days and I'll create a tool to ease this. And that's what actually Slavek did. He created a tool called DFE, which actually was used to template all the files. So you would just maintain templates, and then you would have files with variables, and then you would pick whichever variant you want, and you would get like rendered container image sources. So then we showed the tool to our friends at Software Collections team, and they told us, okay, it's a pretty great tool, but through this we actually created something on our own. So, and that's how we started collaborating on a tool called DisGen. So we pretty much did DFE, and right now we are collaborating on this tool. And it actually does what I just described. So you have single copy of all the files. There are templates, and then we are using a Jinja templating system to put the right values in there, and then we just render the right thing, and we have Dockerfile and we can build it, and we don't need to maintain like 7 different copies of the same file. So the repository from the previous example would look like this. And let's look inside. So for example, this would be the Dockerfile. As I said, like, we want to develop it for different operating systems. So in the variables, we would have stored like what's the name of the base image, and based on the configuration we would pick, we would just substitute the value. So I think that you had enough time to look at this. And if you remember what I was speaking about 10 minutes ago about best practices, so if we imagine that we would put the right values in it, do you think that this Dockerfile follows best practices? Okay, so for every mistake anyone finds, you can get whatever from this web, except for my phones.
You should move copy at the end of the file.
Oh yeah, you're right. So, what do you want? Oh, okay, so just pick something at the end. Yes?
Maybe not hardcode the version and release? Put it in a config.
Yeah, that's a good suggestion. Okay, so at the end, pick something, please. Yeah. Oh yeah, exactly. This was actually the first one I put there. Anything else?
What are shape and sources? You know where it comes from and who is maintaining it?
That's again a really good suggestion. We don't have not enough the right labels. I mean, the labels where the container image comes from is missing. So anything else?
No documentation. How to start it?
Yeah, exactly. There's no documentation. So how to use this thing? Thank you. Yes, exactly. So the issue is that we define new instruction for every label, and like in old versions of Docker, this would create each layer for the thing, but in newer Docker they fixed it. So it's much better to actually inline them and just use backslashes. So yeah, you're right. I think that we code almost everything.
Name is pretty generic, right?
Yeah, that's right. Excuse me? Yeah, we are actually using this convention of these environment variable names, and we didn't run into issues. But that's also a really good point. Like, we could conflict with something else. So the right thing would look something like this, except that. All of the other suggestions which I couldn't think of when I was writing on the slides. So you actually did much better job than I did. So thank you. I mean, so this is this is another good point. So this Dockerfile is obviously not complete. I mean, in order to make it complete, I would need like the project would have to be much longer. Yeah, there is many things still missing, obviously. So thank you for the suggestion. So let's look at the other files for this gen. So there are 2 files which store the variables. So one is called common, that's where you put variables which you want to use everywhere. And the other file is called multispec, and that's actually the heart of this gen. That's where you store all the different combinations and the specific variables for those variants or for those operating systems. and then and finally, when I show you how to invoke it, then you can render the correct Docker file and all the correct files. So also another great thing about this gen is that it actually stores some variables for specific operating systems, because it knows that for Fedora, the package manager is DNF, and for CentOS or RHEL, it's YAM actually. So this is actually stored directly in this gen, and you don't need to store this information. So yeah, this is the first part, and this is the second part where we define all these labels, or I don't know, whatever else we were using it. Yes?
How do you solve if the engine exists different package name for different distribution?
Well, it's easy. I would.
Can you please repeat the question?
Okay. So the question was, how would I store the name if the package has different name in different distributions? So I would just put another variable name in this precise. And basically for Fedora, I would name it Nginx, and for CentOS. And this is how you invoke it. So you just specify paths to these files. Then you specify the matrix or the combination you want. And finally, the file you want to template. And then it will show you the rendered template. Yeah, so, and you can actually use it for anything. Like, it doesn't have to be just container images. You can even template spec files or, I don't know, anything else. So it's not like tied to Docker files or container images. So to wrap it up, yeah, this gen is a tool which allows you to like maintain in upstream files which need to be like processed, you know, for different operating systems and for different versions. And if you're interested, we are having a workshop today at 2 p.m. at M104, and we'll be showing all the tools we'll be talking about today there. So please join us, and we'll show it to you. And I'll pass the word to Eliska.
And the remote. Thank
Okay.
you. All right, so thank you. So the next big area that we've been dealing with is how to configure the container images easily, and how to possibly also allow the end users of our images to add their own configuration. So to basically provide them with some sort of flexibility, because you know, by default, you probably have two choices. You can either ship an image which is pre-configured and covers just a number of specific use cases to the end users, or you can give them a complete freedom, but the image would be probably just useless by itself. So we were trying to look for something in between. And also, along the way, we were trying to find the answers to these questions. So, as I said, to provide the users with some sort of flexibility, and to make them able to specify their own custom configuration, to, for example, get their SSL certificates in the containers, and some of them might want to execute some of their scripts before even starting the service, or on the start of the service. So imagine you have something like this. You have configuration files for your database. So as you can see here, there are some scripts, some bash scripts that you want to start before the daemon is started. You also have a script that you want to execute when you start the service locally, and then you have a bunch of other files. So how do you get it into your image? Like this. So we have figured out that we actually already have the solution. The solution is called source to image, which was originally used for allowing the users to build their images based on their source files, so source code. So basically, you would take a predefined builder image. So we have builder images for a bunch of language frameworks. So I don't know, we have Python, we have Node.js, and they would combine this image with their source code. And the tool that is called source to image would basically output the final application image for them. So we have realized that if we can do this with the source code, why cannot we do something like this with the configuration? And well, the answer was easy. We can. So basically how it works. So as I said, you need basically three things. You need the S2I binary, which is available in form of a Golang binary. It's also packaged for Fedora. I think it's in CentOS as well. So basically you can execute it on pretty much any platform. You need the builder image. There is a bunch of them already available based on Red Hat, based on Fedora, based on CentOS. And you need your configuration files, obviously. So along with the language frameworks, there are also a couple of database images available. So MariaDB is definitely one of them. Postgres, I think there is Mongo as well. And as you see, like creating such an image that uses the customized configuration is very simple. You just run the command like that. And if you want to create such an image and then deploy it in OpenShift, it's very similar. It's almost the same. So the S2I tool, it takes your sources, or in this case, your configuration, combines it with the builder image, and creates a new image that you then run. And in OpenShift, it also automatically deploys the image as well. Yep, so this pretty much solves the problem of how much configuration to provide to the customers or to the users by default, and how much flexibility to provide them. Because by default, we ship some images, and in the end, they can use the S2I tool and inject whatever configuration they need. Of course, the builder images expect the configuration in certain places from where they pick it up, but it's very well documented, so it's really quite simple. So the next example is the example of a Ruby image of a Ruby application. So this is basically this was the original use case for creating. For using S2I for building images from the source code. So to sum it up, we have found out that S2I might be the best tool to really provide the flexibility, unlike with other ways, like for example, bind mounting your configuration files or using environment variables inside the Dockerfile. It is pretty much reproducible because you store the configuration in a certain space, and you can basically always track like which this image was built on top of or from. As I said, S2I is a Golang binary, so you can build these images on pretty much any platform, and like I mentioned, that just the fact that you can store the configuration in GitHub or whatever, you can pretty much figure out like what the image consists of. So it's nicely reproducible. So there are a few links. We have also created a template for creating the builder images themselves. It's quite simple. It's very well described on the GitHub page over there. So you can have a look. But as I said, like we are covering most of the major language frameworks and also some databases, so you can find those on Docker Hub as well.
So we were speaking about creating images, then configuring containers, and now we need to make sure that our containerized applications or our containerized services work well. So we need to test it and validate it. So what do we need for that? So we definitely need to write some tests, right? So write some code which will validate that it's working just fine. So it would be really helpful if we would have like a tool or a framework or a library or something like that which would help us, and it would contain like functions which would help us with the testing. So for example, give me the IP address of the container, or show me which ports are being exposed, or wait for the container to be started, or like this kind of, you get the point. So, okay, so we would have tests, then we would need a test runner, right? So we need to like execute them somehow. So some like a command line tool, which we would be able to like select which tests we want, or I don't know, like tinker with the output, so provide like debug output or strict output. Okay, what else? So we don't want to run that on our laptops, right? We need some like infrastructure which will be where our tests will be running, and this CI infrastructure, it would be really great if you booted new VM for every test suite, and ideally we would select the right operating system with the right packages, and the container engine would be already started, and our image would be already there, and Git repo cloned, so we would just execute it, and our tests would be running. Okay, so is that all? It could also be pretty handy if we had like a generic test suite, right? So we don't need to write everything all in all. I mean, we could create something which would apply to all the containers and all the container images, and it would tell you like, okay, so your Dockerfile is fine. No, this one is broken. You don't follow best practices. What else? Okay, so I really suck at Bash, so I would love it. I could write Python code. That would really help me. And these are actually the questions we were asking a couple of months ago when we started working on testing containers, and we were actually really overwhelmed by all of these. So we tried to address all of them one by one, but yeah, it almost took us 1,000,000 hours. So, and yeah, on top of it, like, okay, so you test that your containers work fine in Docker, but do you deploy your application in production in Docker? Probably not. You use some orchestrating system like Kubernetes or OpenShift, or are there any else? And how do you test in the orchestrating environment? So you can't really start your test suite with deploy OpenShift and then run my tests against this cluster. It's just possible, right? And as I said, we don't like Bash. So there is actually a dedicated session to container testing which will happen tomorrow, so I don't want to spend too much time on this. It will be led by Petr Hráček and Jan Ščotka, so if you are interested in this, please come. But this is just like an introduction or sneak peek. So we actually developed 2 tools to ease container testing. One of them is called MTF. It's a high-level tool for testing containers. You basically start with a config file where you write down what's the name of your image, and how to run the containerized service, and then you can write some tests using Avocado framework in Python, yay, no Bash. And then there is an executable called MTF, and you just run it, and the tests are being run locally. So what's great about MTF that it's really suitable for CI, because it can also prepare the testing environment, so you don't have to create another script to prepare it. The MTF will do it for you. And actually, it can even prepare OpenShift environment for you. I mean, it's the all-in-one binary. All running in the containers, which is just one command. But yeah, it can prepare it, then execute your tests, and say that okay, your container is running in OpenShift just fine. We also have linter for Dockerfiles. So if you are doing the common mistakes, MTF can help you and tell you that okay, you don't follow best practices here and here. Yeah, as I said, so for more information or how this thing looks and how to use it, we'll be showing it at the workshop today, and tomorrow on the talk it will be like greatly described. So when we somewhat had something working with MTF, we actually start showing the tool to other teams within Red Hat. And we got feedback that it's actually too overwhelming. Like you need to write a config file and you need to use Avocado. And we are actually just interested in these functions which would help us with testing. So, so the people actually suggested, okay, so how about you created some kind of library with these functions, and we would really love to use that. And realized that, hey, it's actually a pretty good idea. So what we did, Jan Ščotka from our team took all these like helpful functions. We created a new library called Konu, shortcut for container utilities, and it has all these great functions. For example, like wait for the service to start serving, or get me the IP address, or mount the container file system, and so I want to export all these files and directories. And we already have it. We did one public release, so it's really early, and we don't really recommend for like something stable or production, but really looking for feedback. And recently I actually started calling it Python API for your containers, which we really try to make it to be. And another, what we really try to do is create a container engine agnostic API, so that you would write backends for each of the container engines, and you would implement this agnostic API so that you could have, like in ideal world, you would have one test suite you wrote up, and you could execute it against different backends. I'm not sure if it's feasible, but we are definitely going to try to do it. And that's all for testing. So as I said, if you're interested in this, tomorrow talk, today workshop. And for the final part.
Yeah. So this all is nice, and it definitely eases up or has already eased up our work a lot. But it's, I would say, useless if it isn't automated to some extent. So I would say the automation is a new big area that we will be discovering. As I mentioned in the very beginning, we are now trying to make the whole workflow of the delivery of the building and delivery of images much better, much more sane for us developers. And our next big goals is the automation. How we are imagining it, or how we have already actually started developing it, is to have a number of automated team members, which would be basically robots, so call it services if you want, that would be responsible for executing different tasks. We have designed each robot to be assigned a different task than the other one. And basically these tasks are the tasks that we were doing in the past manually. So we would like to treat these robots as regular team members. So they would have the same rights as we have. They would have, for example, the commit rights to repositories. They would have the same permissions as we have. Only they would be doing all the tedious and mundane work that we would be doing otherwise manually.
Can I stop you? And they would also have real names.
One of the big part of automation is not just blindly automate the whole workflow, but actually to give the other developers some sort of freedom on to what extent they want their workflow automated. So that's why also the team members, the robots, will be fully configurable, and we also want to make them extendable, so that if people come up with any ideas or they realize that they need features, they can contribute to the projects, suggest new features, so something like a plugin system. I did a repo, actually it's an organization on GitHub. It's empty now, but this is where the work will start living soon, hopefully. Yeah, so we're slowly approaching the end. So actually I wanted to ask, like, how many of you actually create their own containerized services? Cool. So I really hope that this was useful, because as I said, like all of the tooling that we've created was based on our struggles, our experiences. So even when you are probably all like seasoned developers, that might come in handy, because you are probably also encountering the same issues as we do. So one of the big things is maintenance, to send updates to your content and don't get crazy. The other big thing is testing. And I think we've also covered this one very well. So automate as much as you need, and also make the testing feasible and even enjoyable for the developers as well. And the last big part, unfortunately, we are not going to deep dive, as this is something that we really are starting. But if you want to learn more about the concept of the robots and automated team members, I would suggest you to attend Steph Walter's talk called Cyborgs, where he will talk about his experience in the cockpit project. Yeah, so here's a bunch of resources to all of the all of the tools that we've showed you. And in the end, I would like to highlight our not only our direct team members and our colleagues, but also colleagues from the upstream projects and from other teams that participated greatly in all of the toolings. And as Tomas already mentioned previously in the testing, we will be having one workshop that will be a deep dive into most of our tooling today at 1 p.m.
2 p.m.
Okay, so 2 p.m., so I have some time. And there will be another talk that will go more in depth regarding the testing tomorrow. So, Peťo. Okay, I think that's it. So, any questions?
Sure. I had a disgen question. So, yeah, a lot of people have done the templating thing. Do you commit the generated files to Git? Like, let's say I want to trigger an app build off this. You commit them to Git? Or...
So, yeah, that's a good question. And the question is if we commit the generated files inside the Git repository. So we were struggling with like how to do it. So we concluded that we commit the main README. So when you open the page on the GitHub, you see all the documentation, but we don't commit anything else. We are thinking like we could store it on different branches in Git, but yeah, we concluded that it's easier to just store the template files. But on the other hand, it will be harder for new contributors to actually just send a patch because they would need to install the tool, figure out how it works. So we'll see. So maybe we get feedback from the community that we should also store the generated files so that it's easier for others to contribute to. We'll see. Yes? So the question is whether we also abstracted in this gen cleaning of metadata of the packager. We didn't. It's a nice RFE. So feel free to work on it or just open an issue, and I think we can actually consider it. Yeah.
Yeah. At the beginning, you said that the less layers is better. What do you think about squashing the layers?
So the question is what I think about squashing layers. Yeah, it's okay. Yeah, I'm not sure. I mean, it's definitely a solution to the problem. So yeah, you can squash the layers and essentially remove the files which aren't supposed to be there. So yeah, it's a real solution. That's actually what Docker, after like 2 or 3 years, implemented in their tooling, so that yeah, you can finally squash layers with Docker, and we didn't have to invert our tooling on our own. So yeah, it's a solution, but I would really love if the tooling itself would prevent you to make these mistakes, so that you could actually, like when creating the recipe for your container image, that you could explicitly tell, okay, this is when the new layer starts and this is where it ends. Like that would, I would love to have that, but we don't have that. Yeah, David?
It's only a suggestion, but we are doing similar stuff. But for the documentation part, we decided if you are developing, putting the template values for labels and variables, we also put comments to it and we generate documentation from it. So you put your documentation inside the sources, and it's very good because if the developer makes a new variable, he needs to document it.
Wow, that's really impressive. So David said that they have a tooling on their own for templating their container image sources, and whenever they introduce new environment variable, they also put the command there and automatically generate documentation, which is really awesome. Any more questions? Or any more questions for Eliska? I don't need to answer anything, all the things. Yeah?
You were talking about custom configurations. These are like configurations built into and you were talking about best practice. What's your best practice guidelines regarding doing configuration during runtime or doing configuration during build time? Where is this line? Should Do you have experience?
I don't think we have any best practices for that.
So yeah, we spent some time working on it. Like, okay, so the question is like, what's the best practice for configuration of containerized services? Whether to store it in the images during build time or whether inject it during runtime. And we actually spent a lot of time thinking about it and trying to polish it. And like personally, I don't think there's a best practice. Like best practice is whatever works for you best. And with source2i, you can actually store the configuration elsewhere in dedicated Git repository, so you can version it and work on it. And then during your, I don't know, like deployment, you can build the new container image with your custom configuration and just deploy it. So if this works for you, yeah, I mean, great. If you want to, for example, use OpenShift and store the configuration in config maps, if it works for you, you have automation for that, yeah, that's great. So I don't think there's like a best practice for everyone.
Yeah, I mean, ultimately, like, probably the best thing is to, like, figure it out on your own, like, what works best for you. So, because that's just one of the optional ways which you can.
Yeah, we are trying to provide you just documentation on how you can do all these things, and it's really up to you to pick the one which suits you best. So we have, I think we have 3 minutes or something like that. So if you have any more questions. And if not, feel free to stop us. Oh, Mike?
Are you generally running MetaTest family manually, or is it part of an automated container build workflow?
Manually.
Yeah, so right now it's manually, but I think like this sprint, we actually had a card to actually create a robot for it to run it automatically. So next sprint, it could be in production, I hope.
No, it will be.
So in case you have any more questions, feel free to stop us and please come to our workshop or, I don't know, tweet to us, whatever else. And thank you very much for coming.
Thank you.
Jedna späť na to krajo, hej, tak tam bude. Because when using source image procedures to